Hello, everybody. This is our class for January 30th. We are looking at, this is day 7 of our class. Last class, we looked at writing equations from problems using geometric formulas, other formulas, and just looking at simply the word problem itself, looking at things that have to be equal or add up to a set thing, or even subtract to a set difference. Today, we're moving on to a little bit different topic. We're going to bring it back to word problems eventually. But we're going to look at percents for a little while here. And talk about percents, we've talked about hopefully you're familiar with the idea that percent means out of 100. Per meaning out of, cent is 100, so it makes sense, comes right out of the word. As we deal with percents, that information is key to how we work with them. So if we're asked to, blank is 30% of 80. We would set that up. 30% is 30 out of 100. And it becomes a proportion for us to work with. Blank is 30, implies that missing number goes with the 30. Of 80, you can read that as out of 80, so the 80 would go on bottom, and you can cross multiply and divide. 30 times 80 is 2,400. Then you can divide by the 100. Here's 24 here. 24 is 30% of 80. You could also have set it up a little bit more algebraically strong way of doing it. Could have put x in here for the missing number. And then you would just cross multiply, period, and then solve the equation. So 30 times 80 is still 2,400. 100 times x is 100x. And those two cross products have to be equal. 100x has to equal 2,400. And of course, we solve for x by dividing by 100. X equals 24. So we get the same result, of course. That's good. And you see the process really is the same. 30 times 80 is 2,400. That's what we got here. Then we divided by the 100. Well, that's how we solved this, was divided by 100. So this here process, cross multiply and divide, is just a shortcut for the full cross multiplication and solving the equation. We know we're going to solve the equation by dividing by the 100. So over here, we just divide by 100 and don't bother with the equation. Well, there are shortcuts. That is the proportion method of percents. And one of the shortcuts is to use a rate method. And the rate method works great in this problem. And there's a lot of problems where it will. We have the full amount. We have what matches up with that 100 in our percent. And we're looking for the portion that matches up with the actual percent itself. And when that's the case, we can go ahead and use this rate method. So blank is 30% of 80. We can use a shortcut by turning that 30% into a rate, which is 0.3 or 0.30. It's a decimal form of the percent. Then taking the 80 multiplied by that. 80 times 0.3 is 24. That is pretty short. We have to be careful because we do run into situations where it goes the other direction, where we have 42 is 70% of blank. Well, now we have to be a little more careful. If we're setting it up with the proportion, 70% is 70 over 100. 42 is 70%, implies the 42 goes with the 70. Our missing number is right there. Rather than doing the equation, I'm just going to cross multiply and divide. 100 times 42 is 4,200. Divided by 70 gives us 60. So 42 is 70% of 60. If I wanted to use this rate method, I would have to recognize them going backwards. I do not have the full amount. I don't have the part that is equal with the 100. I have the other part. So I'm going to still change 70% into a rate, a decimal, 0.70. But instead of 42 times that, it'll be 42 divided by that. 42 divided by 0.7 will still be 60. I'm not going to spend any more time on basic percents because I'm going to assume you guys have had percents in the past. It's one of our prerequisite skills. Taking just a second at percent increase and decrease here. For example, You might have a tax. So we might say that after 8% tax, let's just do this. I'm going to come back to that example, but I want to take it a little bit simpler. Let's say Bill purchases $800 worth of items. If 8% tax is charged, what is the total? So what is the total paid? So here, what they're paying, the $800 is the list price, or the original price. That represents 100%. But we're adding a tax to that. We don't know the amount of the tax, we know the percent is 8%. So we're going to end up with 108%. So as we look at this, we could find 8% of 800. I'm going to use the rate method here. 800 times 0.8 is $64. But that's just the amount of the tax. We would have to add it to the 800 to get the total, which you can see would be 864. Or we could use 108. That is the amount plus tax. List price plus the tax. That'll be the amount paid, actually. So we just take our 800, and instead of times, that should have been times 0.08, not 0.8. Maybe 0.08 is 8%. Sorry, is the 64. The 800 would be times 1.08. That's 108%, which is going to give us 864. Now, in this case, we could find the 8%, multiply by the 0.08 to get 64, and add it on. Or you just find the 108%, multiply by 1.08. We get the same answer, and it's about the same amount of effort. But we run into problems where it's the other way around. This is the example I was about to show you earlier. Let's say that after 8% tax, Pat pays $378. How much tax was paid? So we have that original amount. I'm just going to call it the list price again. We added tax to it to get the amount paid. It's the total amount paid. I'm going to make this into a table here for us. We've got percents over here, and this would be the dollars. We know the 378 is the amount paid. That's the only dollar amount we know. Well, on the other side, we know that the list price is 100%. That's the full amount before we start anything. Tax was 8%. So the amount paid was 100 plus 8, or 108%. Now, we work with that 108%. Remember, what we're finding is going to be what corresponds to 100%. That'll be the list price. We do 378 divided by 108 would be 1.08. It gives us $350. That's the list price before tax. So we do still have to go back and subtract the 378 total minus the 350 here gives us $28. That's the amount of tax. And yeah, that adds up. 350 plus 28 is 378. So the answer to our question here, the amount of tax paid, is $28. Similar with a decrease problem. We might have, after a 12% discount, Sam pays $176. How much did Sam save? So again, we have the original price, we call it the list price. But this time it wasn't adding a tax, we're actually subtracting a discount to get the amount paid. So we got percents and dollars here again. Dollar amount 176 is the amount paid. List price, as always, we start out at 100%. Now it's a 12% discount, so we're subtracting 12%, which means the amount paid is 88%. So what we're using now is 88%. If we do 176 divided by 88 by 0.88, which is our percent, whenever we divide by the percent, remember it takes us back to the 100% here. The amount that represents is the list price. So we divide 176 divided by 0.88 is $200. So that's our list price is $200. So we have to find the discount. Always subtract the 200 minus the 176 is $24. That discount was 24. Notice in both of those last two examples, I could not use the percent that was given in the problem. Here it was the 12%. I had to use the 100 minus the 12. The 88% was the percent I had to use in my calculation. The 12% helped us find the 88, but from there it was not used in the calculation. Same up here. We could not use the 8% of tax. We had to use the 108% in our calculation. Again, we used the 8% to find the 108, but that was the end of its use in the problem. Well, one of our applications of percents in rate method, especially of percents, is in mixtures. And we actually have two types of mixtures we're going to look at here. We're going to look at mixtures of chemicals, we're going to look at mixtures of investments. But in a pure mixture, in a solution, there are two things that are put into it. There is a solvent. Solvent. This is usually the filler. Usually, in many cases, it's water or other some sort of neutral liquid. And then there's a solute. And this is usually the active ingredient. Even if it's just salt water, the solute is the salt. That's the active ingredient. If it's a medication, you have iodine or whatever in water. So the amount of active ingredient in other words, the amount of the solute is equal to the rate of the concentration times the amount of the total solution. So if we have 400 milligrams of 18% solution, how much of our active ingredient, of our solute, is in there? Well, the amount of solute is 18%. As a rate, that'd be 0.18 times the total amount of 400 milligrams. You multiply that out, that is 72 milligrams of that solute. In investment, there's a similar relationship. We're assuming 1 period or 1 year investments. So any compounding would be equal to a year, or if it's shorter than that, the percent given is just for that single period. We're going to look at annual investments pretty much here. The interest, the amount of interest for 1 year is just equal to the percent, the rate, times the principal, which is the amount of money you started with. So let's look at the interest on the interest for $4,000 at 8% for 1 year. Our time is going to be assumed for these investment problems to be 1 year, unless otherwise stated. The amount of that interest is that 8%, is a rate that's 0.08, times $4,000. I have a habit of when I write that percent or that rate in front of another number, I put the other number in parentheses. Just it seems clearer to me. That's just 0.08 times 4,000, which comes out to be $320. That's the amount of interest on that investment. We're going to look at mixtures here. Let's say we're going to mix 600 milligrams of 8% solution with 300 milligrams of 23% solution. Let's see what we get. Well, we're adding together two solutions. So our first one is 8%. We're going to combine it with 23%. And we're trying to figure out what percent that gives us. It's not going to be 8 plus 23. It's not going to be 31. But we are combining them. The amounts of each, well, we're given 600 milligrams of the 8%, 300 milligrams of the 23%. Well, that has to add up. 600 plus 600 plus 300. We better have 900 milligrams of whatever we end up with. So now let's look at the amount of that active ingredient that went into each. The active ingredient combined, it stays constant before and after the mixture. So here we have 0.8, or 0.08, I should say, for 8%, times 600, plus 0.23 for the 23%, times 300. And those two combine to make, we're going to call that X percent, X for now, times 900 total milligrams. So to solve this equation, we're going to combine 0.08 times 600, that's 48. 0.23 times 300 is 69. X times 900 is 900x. We're going to keep combining over here on the left side. 48 and 69 is 117. 900x. And now we'll divide. Dividing by 900. 117 divided by 900, I believe, is 0.13. Just double checking here. And it is 0.13 equals x. So concentration of 0.13, which means that is 13% solution. Same type of thing can be done with an investment problem. We invest $2,000 at 3% and $4,000 at 6%. What's the total yield of our total $6,000 there? Well, same thing. We've got 3%. We're combine it with 6% to get some mystery percent total yield. The amount that we invested in each, we put 2,000 in the 3% and 4,000 in the 6%, which means the total investment was have to add up to $6,000 total investment, 2,000 plus 4,000. So again, it's that 0.03 for 3% times 2,000. We're going to add that 6% as 0.06 times 4,000 has to equal, well, that's X percent. X is a rate, actually, not a percent there. 6,000. Now we'll combine. 0.03 times 2,000 is 60. 0.06 times 4,000 is 240. X times 6,000 is 6,000x. We'll combine 60 and 240, make 300, still equal to 6,000x. And to solve for x, we'll divide by 6,000. So we've got 0.05 equals x. So 0.05 is the rate, the percent would be 5%. Most of the time, we are not mixing two random things to see what they're getting. We have a desired thing that we need. So let's look at a percent. And we're going to ask this one in a simpler form to start out with. Because that's how much 18% solution should be mixed with 240 milligrams of, let's see here. Let's actually make this 43% solution to create 28% solution. So again, we look at what we're mixing here. We are mixing 18% and 43%. And now this time we know what we're creating is going to be a 28%. This percent, by the way, this final percent always has to be between these two. Can't be outside of them. No way it can happen. Look at the amounts. Well, the 240 goes with the 43%. We're looking for how much 18%. That's going to be our x. Well, the amount of 28% is going to be found by adding those two together. Up above, we added those two amounts together to get a total amount. Even though we're missing one, we're going to do the same thing here. That's going to be x plus 240. So our equation, 18% will be 0.18 times x, plus 43% will be 0.43 times 240. That's going to equal 28% of 0.28 times x plus 240. And now we'll solve for x. 0.18 to x doesn't change. 0.43 times 240 is 103.2 equals, over here we have to distribute 0.28 times x is 0.28x. 0.28 times 240 is 67.2. Now we've combined everything we can on each side. We see there's still an x on each side, so we'll get rid of the smaller one, 0.18x. So this is gone. We have 103.2 equals 0.28 minus 0.18 is 0.1x plus 67.2. Now we'll solve. We'll subtract the 67.2. Oh, what does that give us? Just 36 here? Here, that's gone. So this is just 0.1x. And finally divide by the 0.1. So it's 360 equals x. So I go back up, see what x was. X was the amount of the 18%. These are all in milligrams. So this is 360 milligrams. And I was asked how much of the 18%. So that is our solution, our answer. Now again, most of the time, we have a set amount of the product that we want. Here, this made it a little bit easier because we knew the amount of one of the ingredients. And we just, whatever the product came out to be, we let it come out to be that. It's a little more complex when we have a set amount of that product that we want to have. So let's say when mixing 41% and 59% solution, how much of each should be used to create 480 milligrams of 47% solution. So again, we've got our ingredients. We're mixing 41% and 59%. We want to get 47% as our final result. The amount that we know is 480 milligrams is going to be the final amount. We don't know these amounts, but we know they have to add up to that 480. I'm just going to pick one of them to be X. Doesn't matter which one. I usually pick the larger percent, so the 59% will let be X. 41, that has to be 480 minus X. If the total is 480, if this one is X, this one has to be the total minus the other amount. So 480 minus X. So this equation becomes 41% is 0.41 times the amount of 480 minus X plus 59% is 0.59 times the amount of X equals 47% is 0.47 times the amount of 480. So now we combine what we can on each side here. On the left side, we have 0.41 times 480 is 196.8. 0.41 times negative X is a negative 0.41X. Here we've got 0.59X. This is why I always let X be the larger percent, because when I combine those, I'm going to get a positive number instead of working with a negative. Over here then, 0.47 times 480 is 225.6. So now I'm going to keep combining. On the left side, I can still combine my X's. So the 196.8 doesn't change. Negative 0.41X and positive 0.59X is a positive 0.18X. Now I will subtract. As I solve for X, I'm going to subtract 196.8. So 0.18X equals, oh, what is that? 28.8, I believe. And then I will divide by 0.18. This is 160. So X equals 160. Now let's go back and check. We want to know how much of each should be used. Well, X is 160 milligrams. That's the amount of the 59%. For the 41%, we have 480 minus X, so 480 minus 160. That's 320 milligrams of the 41%. Similar things can happen with our investment. Tim invests $12,000 in a combination of 3% and let's just go 3% and 5% investments. if Tim earns a total of 4.5% overall, how much was invested in each? So again, we're combining 3%, 5%, trying to get a final result that's 4.5%. We know the total invested was 12,000. So whatever these two amounts over here are, they have to add up to the 12,000. So again, I'll let the larger percent be x. So it has to be 12,000 minus x, the total minus whatever went into the other investment. So our equation, 0.03 for 3% times 12,000 minus x plus 0.05 for 5% times x equals 4.5% is 0.045 times 12,000. And now we simplify on each side. We combine. On the left side, 0.03 times 12,000 is 360. 0.03 times negative x is negative 0.03x. The 0.05x doesn't change. We can keep combining here. Let's just do that. Normally we keep combining on one side anyway. So we're going to combine the x's. Negative 0.03 and a positive 0.05 is a positive 0.02x. On the other side there, 0.4045 times 12,000 is 540. And then I will solve for x. We'll subtract the 360. So 0.02x equals 180. And we'll divide by 0.02. X equals 9,000. So let's go back and look first of all, what does x stand for and what we're trying to find. Well, x stands for the amount invested in the 5,000%, or 5%. So $9,000 was invested in the 5%. We're asked to find how much was invested in each. So 12,000 minus x would be minus 9,000 is $3,000 in the 3%. Now there's another wording that can be used there that might be a little bit confusing, but I'm going to throw it out there for you. Instead of giving the final percent, they might just give the final amount of interest. So let's say that Pat invests $10,000 in a combination of 5% and 6% investments. If Pat earns let's do $520 in interest for a year. How much was in each? I'm just going to put how much in each. Keep it short. So again, we're combining 5% with 6%. We don't know that percent. 520, the interest actually combines the percent and the total for us. So we're just going to put that $520 in interest over here. That is the x times the total of 10,000. We could figure that out to be 5.2%, but we don't need that. We want the 520. We want the total interest anyway. Up here when we're solving, when we multiplied this out to get $540, that was the total interest earned. So by giving us the total interest, they're saving us that step. On the left side, we still need to do the amount invested here. I'm going to call this X, and this will be the full amount of 10,000 minus X. So the equation is going to be 0.05 times the amount of 10,000 minus X plus 0.06 times X equals just 520. My pen to work here. There we go. So let's combine. We have the 0.05 times 10,000, which is just going to be 500. 0.05 times negative x is a negative 0.05x. Nothing to do with the 0.06x yet. If we keep combining, was a negative there. Negative 0.05 and a positive 0.06x is a positive 0.01x equals that 520 doesn't change. Now we solve. So we can subtract 500. 0.01 x equals 20. And we divide by 0.01. X equals 2,000. So now again, let's go up and see what X represented. X represented the amount in the 6% investment, 2,000. We want to find both the 5% and the 6%. So that's going to be 10,000 minus X, we minus 2,000. That's $8,000 and the 5%. So we have that mixture. I will post another video along with this that goes over a lot more examples of mixture problems. It'll be focusing on the chemicals, but it'll apply to both. It'll be very easy to apply it. The last thing I'm just going to throw out there is I think you guys should probably be familiar with it, and that's just data graphs. Data graphs like circle graphs, bar graphs, and line graphs. Circle graphs, of course, are sometimes called pie charts or pie graphs. And circle graphs focus on percents. So let's say we're looking at the breakdown for a class. I have a small percent of A's, larger percent of B's, and C's, and a small percent of D's. Now, the size of that slice of that pie, this should be in the center here. The size of that slice tells us what portion each is, but let's just label percents in here. Let's call this one, let's say 16% get A's, 35% get B's, 40% get C's, and that leaves 9% with D's. We're going to assume nobody failed this course. Well, back to those, again, applications of those percents. Out of 300 students, how many had a B or better? Well, that would be a B or an A. So we have 35% and the 16%. Which is 51%. So we're going to take our 300 students times 0.51, which will be 153 students. So 153 out of those 300 students had a B or better. So over half were an A or a B. Bar graph, we're just strictly given raw numbers. The circle graph or pie chart gives percents. The bar graph gives raw numbers. Look like this. And this will be labeled over here, as 10, 20, 30, and so on. One of the weaknesses of a bar graph is it's not exact. If I look at this one, I trace it over, was that 12, 13, 14 students? Getting the exact number of it is very tricky. In fact, it's almost impossible on a graph. If you want an exact number, you go back to a table that would give you that exact number. Somewhere along with this chart here, there is a table that said, so here's our grade, this is our frequency, A, B, C, or D. It said, well, 16% were A's, that's 48 A's. 35% were B's, so that's 105 B's. 40% were C's, 120 C's, leaving us with 9% D's, or 27 D's. Those were used to find the percentages for that circle graph, the pie chart, and those are the raw amounts here. So we see that D, I made my scales off here. It should have been 2030 or 2040 and so on. Let me correct that. So 20, 40, 60, 80. So that would have lined up. But again, from the graph, it's very difficult to give the exact number of D's, or even for any of the others for that matter. The line graph gives a change. It doesn't compare different things. It compares one thing over time. So you might have your grade by exam. So let's say exam 1, exam 2, exam 3. Now this is not the grade on the exam. This is your grade, your overall for the course. So your homework and quizzes and everything else figured in. So this is up to 100%. So 20, 40, 60, 80, 100. Let's say after exam 1, your grade is at 83%. After exam 2, your grade is at 81%. And after exam 3, your grade jumps up to 88%. That's a pretty flat graph. So what we could do to that to make it a little more readable would be this. Since none of your grades go below 80%, and none of them go above 90, we could just zero in that vertical axis between 80 and 90. So we said after the first exam, your grade was 83. After the second exam, you dropped to 81. After the third, you went up to, I believe it's at 87. So now we can see, just a little closer, your grade goes down and up. It's a little steeper here, so it's going up here faster than it was going down there. So very quick to see the highest and lowest, but again, if you wanted the exact amounts, it's at 83, 82, it's not quite, not simple to find an exact amount. Is that 82.7 or is it exactly 83? So we would have a table somewhere that would have those exact amounts. The graph is quick for comparing when was your grade higher, after exam 2 or exam 3? Did your grade rise between exam 2 and exam 3 or fall? Things like that. Or when was your grade the highest? Same with any of these others. Which grade had the most students that had that grade? You can pick out C is the tallest bar, things like that. Okay, that is it for today's material. You should be looking now at homework. It's actually all of the homeworks now for week 2, but homework 2C is on the table. That's listed as being due this Friday. Again, final due date is for Monday. So for Monday, this coming Monday, you should have homeworks 2A, B, and C. And there's going to be quiz 2 coming up. Those will all be due at 11:59 p.m. So if you have any questions, you do have time to ask questions on Monday, and we can work over them so that you can get that stuff finished up by basically midnight Monday night. Hopefully we're feeling good about stuff between the lectures and my math lab. Hopefully you're doing okay with the material. Otherwise, we can catch everybody up when we come back on Monday. Have a great weekend.